Alright, the first question we're going to attack today is question 10 of multiple choice. I have no multiple choice answers on the board, but I'm going to demonstrate how you would do this. Okay, it's a lever. The first thing to work out in this question is it's a lever. There's a force being applied on the very end. This is the actual lever. Alright, there's the lever itself. We need to know where it's pivoting. We need to know where the pin is. We need to know where the fulcrum is, if you use physics, sometimes they call it. And that is right here at the end. See that triangle? Okay? That is a bolt or a bearing or something going on right there. So that is where all our measurements are going to come from. That's where all our forces are referenced back to. It's all relative to that location. Okay, so the very first thing we need to know is it's a lever and it has 10 kilonewtons of force applied to the very end. And in that case, it is 10 kilonewtons on the very end. So, in equilibrium, we know that if you've got two forces or more, if it's in equilibrium, they're going to balance each other out. In this case here, we've got a force going down. Okay? Let's say, for instance, I'm going to say that's moment 1. Okay? We should know now that moment equals force times the distance. And that distance has got to be perpendicular. Okay, that means at 90 degrees. It's got to be at 90 degrees, that distance to that force. Okay, otherwise, we haven't really got the true distance. So in this case here, I've been generous in giving you the force. And is the force perpendicular to the lever? Yes, it is. So if it's perpendicular and they've given me the measurement, I can use that measurement. Okay, in this case here, moment 1 is, I always write my knowns and unknowns. Distance 1. Okay. Okay, so in this case here, I need to know how much force. It's 10 kilonewtons. Right? If you want to work in kilonewtons, that's fine. What's our distance? How far away is that force from the pivot point? It is 1300 millimeters plus 600 millimeters. That is 1900 millimeters. Okay, we're working in meters, so that is going to be 1.9 meters. Okay, so I'm going to write 1.9. Okay, so in reality, my moment 1 equals 10 times 1.9. Force times distance, which equals 19 kilonewtons every meter. Okay, it's 19 kilonewtons per meter. That's the moment that's occurring. Hence, that now tells us what the moment 2 must be. The moment 2 is this one here. Okay, and that is why the question is saying, what is the force acting at this point? Okay, moment 2. Okay, moment 2 is going to equal force times distance. Okay, and I know from experience that moment 1 equals moment 2 because it's in equilibrium. Okay? And in that case, our moment 1, moment 1 is going to equal moment 2. Right, so in this case for moment 2, I know moment 2 is going to equal 19 kilonewtons per meter. Okay? I don't know what the force is, but I do know what the distance is. Okay? Is the distance perpendicular to the force? Yes, it is. You can see there, 90 degrees to the beam, or the and that handle is, the distance that force is applied from the pivot point is 600 millimeters. In that case, it's 0.6 meters. Okay, so if it's 0.6 meters, and I know moment equals force times distance, moment 2 is 19. So in that case, moment 2 equals 19 kilonewtons per meter. Okay, and that equals F times 0.6. Okay, so if 19 equals F times 0.6, I know that 19 divided by 0.6 equals the force. And 19 divided by 0.6 is 31.67 kilonewtons. So for this handle to be equilibrium, there must be a moment applied that is equal to the other one, and we hence have a force applying here of 31.67 at 600 millimeters, which is only about this big. Okay, that's how you do it.